This is our simple Pendulum Lab setup. Same ring stand. Notice how it's set up over the edge of the table. We're hanging the pendulum from the threaded screw at the end. You're going to need a couple meter sticks, stopwatch. The mass I have hanging over the end right now is one of the pyramid-shaped ones. You might get some washers, or the other option. All of us are going to have slightly different masses, but we're looking for little g, the acceleration due to gravity, and the mass shouldn't matter for the period of a pendulum, so we should all get the same result. The first thing I'm going to measure once we get our pendulum attached, and we want to make sure it's not really spinning around, we'd like for it to just be sitting still. So this thing's still enough for me to get going. I'm going to measure the length. So the length is always going to be measured from the pivot point. This is the pivot point up here at the top where the string is going to be turning. So I'll measure with my meter stick from here all the way down to the center of mass of the object, which with the pyramid thing, center of mass isn't going to be right in the middle because it's got more mass up top. So maybe 2/3 of the way or so, maybe right where it's got this little number 2. I don't know if you can see that. That might be right around where the center of mass is. You have to estimate that a little bit. The washers, I'd say the center of the washer, where the hole is where the center of mass is. All right, so we measure from the very top, where the pivot point is, all the way down to the center of mass of the object. That's the length of our pendulum. We record that in meters. Then we get this guy in motion. We want to make sure that it's going to move parallel to my table here, back and forth without scraping the table. I only need to displace it a few degrees, less than 15. Otherwise, it's no longer simple harmonic motion. It's no longer a simple pendulum if you swing it back really far. So I've displaced it a little bit. Look at it go. All right, nice and smooth. So I make sure it's not scraping against the table. We're good. And that's when I get my stopwatch. So say I have my stopwatch. I would start my count, say when it's closest to me or furthest away at maximum displacement. So let's say start, 1 cycle, 2 cycles. We want to count up at least 10. And then if it's moving really fast, you might need to count up to 20 cycles or maybe 30, depends on your length. If it's moving really fast, make sure that you count a lot of cycles. You'll get a better value for the period. All right, so let's say this is 9 and 10. I'll stop it right when it comes back to me because that's when I started it. Say that was 10 cycles. I would take my 21.83 seconds, divide by 10. I got 2.183 seconds for the period. Good to go. All right, next time we change the length. So all we got to do to change the length is grab this thing and wrap it around. And let's see if I can do it one-handed. If you keep the screw, if the screw is fastened in far enough, then the screw will no longer be able to spin from the weight. If your screw is spinning and changing the length, you don't want that. You want the length to be fixed. So I've wrapped it around a few times, so therefore I've decreased the length of the pendulum. Now it's shorter, so I go back and measure its length from the pivot point down to the center of mass, and now I should have a different period. And I record that one. Once you get, the lengths are up to you. Once you get all of them, though, we're going to use that to determine little g.